Today, these are the topics we are going to discuss: sampling distribution, their techniques, normal distribution, and the center limit theorems. These are the very basic and important terminology of the statistics. If you want to further study any books, watch any videos, and solve any problem, so you must be in contact with these basic technologies, terminologies. So I would say, so please try to understand, because it will be repeating in all the upcoming videos and your study purpose also. So before understand all these techniques, as you know, the statistics is the study of the huge data set, right? So suppose if you have to study some huge data set, for example, if you want to know what is the average age of any country, or what is the height of the any country citizens. So this is a huge data set, right? So suppose, and those are called the data set. So suppose these are the citizens for which you want to know the average height or average weight or things. So in the statistics, this huge data set on which you want to work, this data set is called the population. And population is a biological term, but don't confuse. This data set could be the living, non-living. For example, how many machines or the machines of in a factory, right? This is also a data set. We can say this is the population. Or the event is being generated from the IoT device per day. Those are the huge data set. We can call it the population. So, but thing is that we have some terminology to find. If you want to know some important information for this population, so we have some terminology, statistical terminology, and those is called the parameters. What are those terminology out there? First, n means number of data, number of items in the data set. So that could be anything, right? So suppose if you say what is the average age of a country, that is also a population. But if you want to reduce the population size, I can say what is the average age of a particular city, that is also a population. So depend upon your use case, population could be anything. So just for the time being, you understand population is a huge data set, right? So there are some parameters out there in the population. Number of items will be denoted in capital N. And this is called the mu, that is the average or mean. So suppose if you are interested to find out the average age, so what if we do that, you have to calculate, add all the age divided by the n, right? That is the average age. And third is called the sigma, that is the standard deviation, or you can also say the variations. So this sigma will denote and will explain you how many varieties of data are there, what is the variance among those data set, that we denote by the sigma. So now, but if you want to know something out from this huge data set, right, it is not easy. Example, so suppose if you want to take the what is the average marks obtained per year of a big university that have the 100,000 students or the 10,100 students, right? So it is not possible, even though sometime your population could be infinite. Take the population or take the youth of the complete world. So sometimes your population is the infinite, even though population is finite, but it will require the money, use money for find out this data, or the manpower, or the materials, or the time. We call this is the 3MT. Means money, manpower, materials, and the time, to find out something from the population. So that is not possible eventually. So what we used to do, we take some few data out of this. This data could be the random data or by any means, and this is called the sample. and this sample would be representative of the population. So if you take some sample and you will find out the mean or the standard deviation that could be near with the population's mean or the standard deviation, because it is not possible to research on the whole data. We take the sample, but some terminology is different when you take the sample, and that terminology is called the statistics. So for the same, for the number of item we use the n, for the average mean we call the x bar, and for the standard deviation we use the terminology s, right? And again I am saying this sample is the subset of the population that represent the population's statistics for their parameters, right? But if you see that and this mechanism, right, so you will take the sample and do that, this mechanism is called the sampling. And here we took the random sample, that is called the sample. But again, so if you take this part of the data set, that might be not resembles with the population whole data set. So you might be you have to some different techniques to take the sample, and that is called the sampling technique. That also we will study that. So we have some different technique then by which you can take the sample and try to find out the statistics. So this is the definition of the sampling, means your sampling should be representative of your well-defined population. Okay, so as I said, there could be many techniques for the sampling. You can take the sample from here and from there, and some sample from all the directions, right? So we have the two broadly divided categories for the sampling. One is the probability sampling and second is the non-probability technique sampling. So these are the different sampling techniques. So we are studying now sampling technique. So first you understand what is the difference between probability sampling and the non-probability sampling. Probability sampling means each member of this population should have the equal opportunity of being selected. So when I do the random sampling, so I can pick up anyone. So every member has the equal opportunity. Then you call the probability sampling. But in the case of non-probability sampling, not all the member of the population has the equal opportunity. Means as per my convenience, as per my easiness. So I will take, because I am staying here and this geographical area here, I will take the sample from here only. So as per my convenience, or I can call some people, get their data from this side. So that is called the non-probability sampling. So we are not going to discuss those things, we will discuss these things. There could be many kind of the sampling technique, but here broadly I am going to discuss about the 4 different kind of the sampling technique: simple random sampling, stratified random sampling, systematic, and the cluster. So let me understand one by one. So I will go the first one, random sampling. Random sampling is the complete lottery system. So what happened? If you want to, suppose this is the population is of the 600, suppose, and you want to need this is the population, right? So you see population, and you need the sample of the 12. So how you can take that? So take one bucket, put all the name, and randomly pick up the 12 name. That is called the very simple random sampling, right? So one example, suppose you have the one college, they have the 600 student, and you want to create one cricket sports team, and you will know for the cricket we need the 12. So how we can choose the 12 from the 600? All the boys say no, I want to join. So you should have some technique for the fair selections, right? So this is the one easy technique, the simple random selections. So you put all the 600 name here and then pick up the 12, right? This is the simple random sampling. But now suppose, now the case, this sample is the heterogeneous. Heterogeneous means you have the varieties of data, right? So you have the variety of data. So suppose here we have the different gender, different age, different IQ, different financial people, and you have to pick up from all the categories. So if you choose the random selection, so it could be possible all the people could from the one category or the two categories, right? So you cannot cover all the category, all the different kind of categories doing your sampling. So that's why different technique is called the stratified technique. So in the stratified, first you made the strata, this word strata, that is called the homogeneous subgroup. So first you make the strata. How many categories of data are there? You divide those data into different strata, and on that strata again you do the sample randoming. Then you will get all those things. So if you take one examples, what I am trying to speak here. So take the same example, the cricket sports team. So what happened? You have the 600 people here, right? 600 students, and you need the 12. But if you see in cricket, this is the players, the team member could be combination of the batsmen. So suppose you have the good, you want some good batsman, you want to get some good bowler, you want to get some good fielder, you want to get some good wicket keeper, right? So what you will do, you will divide this 600 into these 4 strata, right? You divide into 4 strata, and here you can do the simple random selection. Here is the simple, and I need the 12, so take the 4 from here, take the 4 from here, take the 3 from here, 3 from here, and 3 from here. So you will have the all kind of the categories you will have in your sample. That is called the stratified. Now the systematic. Systematic is little bit different. So what we do in the systematic? So in the systematic random sampling, what we do? We divide the entire population in some certain order. That could be the ascending order, and that could be the descending order, right? Any order. Then you decide what would be your sample size. So suppose in my example, I want the sample size 12. So what you have to do? You have to divide the complete population by your sample size and find out the one group number. So in this case, we have the 600, I want the 12 size of sample. So we have the 50 different category, right? So this is your one category. This is one category of the 50 people. This is another category of the 50 people, right? So this is already in the order. So this box would have the from 1 to 50. This will have the 51 plus 100 and so on, right? So first box you have to pick up the randomly. So suppose randomly I pick up the 25th one. So I got one, right? Now from second box, I will choose 25 plus k. What is the k? 50. So 25 plus 50 is the 75. So I will pick up the 75th one. Third one, 25 plus 2k means 25 plus 100. So I will pick up the 125th. And here so on, 255 plus 3k. So this is called the systematic random sampling. If you talk about the cluster random sampling, so this is similar to the stratified. Here also we divide our population into some cluster, but difference is that in stratified we make the custom strata, custom subgroup, but here in the custom rendering we will take the advantage of the existing natural group. So the country, right? This is already defined. This is the city, age, gender. So we take the advantage of the natural grouping, and keep in mind those should be the mutually exclusive. So when you make the one group of the age, so those should not go to the gender, right? If you the persons who are in the gender, the data should be in the gender should not come into the age group, right? That you have to keep in mind. Then once you make the subgroup, then again apply the sample random sampling and take your sample. So these are the sampling technique. Yeah. So far we came to know what is the population and what is their parameter and what is the sample and the statistics, and also we have already seen that how different kind of the techniques by which you can take the different kind of the sample, right? So now suppose these are my population, and for example just we are considering the height of the any countries of the citizens. So if you take the data distribution for the population, that might become any shape, right? So if you're getting confused with that the distribution, so instead of the picture you can just consider that this is the 5 feet guys, this is the 6 feet, and this is the 5.5, and this is the 4.5, or you can take 3.2. You consider some number, okay, so that it will be easy for you visualize. So these are the numbers. So what you do, that is the, you can put all the heights here, all the heights and their occurrence. How many, suppose if this is a 5.5 or this is the 5, this is the 6. So how many 5 came, how many times 6 came. If you make, you can get this kind of the distribution of the height in the population, right? The same thing if I take the sample, right? And if you make the same distribution for the sample. So suppose my sample size here n is equal to 10, and if the population size is equal to suppose 10,000. So obviously their combinations of the distributions will be different. If you take the sample distributions, that might be different, right? So something like this will happen, that. Like this. So now if you take the one sample, so what did you do? You take the 10 data here and find out the mean. How did you take the mean? You add all those data. Suppose here this is the 3.6, here this is the 4.2, here this is the 5.5. You add everything and divide by 10, you get the mean, average, right? And that numbers you arrange here, these 10 different numbers. So now this is the one sample. Similar way, if you take the another sample, so suppose I take another sample, different sample. So this was the first sample. You can say the x bar 1. So what you do? You take all the n, and size is the same. All the sample size is n is equal to 10. So we are considering the n element in the each group, in the each sample. So you take the one sample and find out the mean. Another n, one sample, find out the another mean, x2 bar. Another sample, find out the different mean. And obvious, when you take the different data, your mean would not be same, right? It would be the different. But only keep in the mind the sample size is the 10. So all the sample has the 10 element. So now you got the sample. Now what you do, that you draw, this time you draw one distribution, take all the samples mean. So these are your mean of each sample, right? So suppose this would be like this, and this side, this is the x-axis and this is the y-axis. Y-axis, either you can keep the frequency or the probability. If you want to use probability distribution, then keep the probability here. How you do the probability? First, what you do, so suppose this is the average, this is the mean, right? So suppose your mean start from 3 and went into the, suppose the 7, and 3.5, 4, 4.5, 5, 5.5, 6, 6.5. You take one x1, and suppose x1 is coming the 4, right? So yeah, 4 between the 4 to 5. This is your x1. Now you take the x2, sorry, x1 bar, this one. Now you take the x2, suppose x2 is here. Then the x3 might become here. Then the x4, x6, x7, x8. So you all the possible combinations of the group you take, and you take the diagram, and you will see your diagram is coming like this. This is called the sampling distribution. Means you took the sample of the different samples, find out the mean, and draw the distributions. So the sample distribution is saying a distribution of the statics made. This time statics could be anything, but this time I am taking the mean of the multiple random sampling. So I took the multiple random sampling and draw from the specific population and draw the distributions. And obviously if you take the different sample, your distribution will be different, right? So distribution is depend upon from which kind of populations you are taking the sample, what is the size of the sample, and what is the method, by which method you have taken the sample. That we have already seen that we have a different kind of the method by which you can take the sample, right? So this is called the sample distribution. And if you see, these diagrams looks like the normal distribution. So now we got one new term, normal distributions. So first we understood, right? You take the different sample size the constant for all the sample, take the mean of each sample and draw the distributions. When you draw the distributions, it will similar look like the normal distributions, right? So now we will study what is the normal distribution.